here they have given the mass of the earth is, so all these are the constant values. Okay, the mass means weight of the earth is how much? 6 into 10 to the power of 24 kilogram, and the weight of the sun is 2 into 10 to the power of 30 kilogram. If the average distance between the earth and the sun is, the distance is how much? Between the sun and the earth, 1.5 into 10 to the power of 11 meter. So according to the weight of the two bodies and according to the distance, we can calculate the gravitational force. Okay, so then calculate the force exerted by the sun on the earth, not the gravitational force. This is the force which has between them. So what will be the force exerted by the earth on the sun? So how the earth gives the attraction to the sun? Okay, so this is the equation. We use this equation. Which equation? This equation. Okay, m1 into m2 by r square, distance. So the weight of the both sun and the earth. So the sun and the earth is what? 6 point. So you see in your textbook, you will understand. Please take the page 160. Here it is not given properly. So follow the textbook, I will explain to you. So in the place of m1 they put the mass of the earth and the mass of the sun. Okay, so gravitational value also is there, na? So 6.67 10 to the power of minus 11 is the universal gravitational value, which is constant. Okay, which never changes. Okay, gravitational constant. And the next one, for the mass of the earth is 6 into 10 to the power 24 kilogram, mass of the sun is this much, and average distance between them is this one, and G means universal gravitational constant. Constant means same, universe दुनिया में कहीं भी same value. 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. Okay, so here we keep F is equal to this value G according to the equation. So this is like this, na? m1 into m2 by r square. So in the G place this one we write, in the m1 place mass of the earth, m2 place mass of the sun, and r square place the distance. 1.5 in 10 to the power of 11, it is a square or square we keep. So after multiplying, dividing everything, we get the answer. This is the answer we get. So this is the Newton means what? SI unit of the force, attraction, force. Okay, force SI unit is what? Newton, N, capital N. So which is this much force, the earth is attracting the sun or sun is attracting the earth. Okay, so this is the one. And next topic we see about the gravitational acceleration G. Please don't forget what is the gravitational constant value is, means 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. Okay, so this is. So actually what is the acceleration? Acceleration means what? Change in velocity. Okay, change in velocity. So actually velocity means what? Velocity means going in a direction with the same speed. With the same speed when we going in a direction, particular direction. Okay, so velocity means going in a same direction with the same speed. Otherwise acceleration means what? Change in velocity. That means changing in the direction. It is the acceleration. Okay, but velocity means what? Going in the same direction with the same speed. But acceleration means change in velocity. That means change in the direction. So change in the direction, it is the acceleration. So here we see gravitational acceleration. Gravitational acceleration has the small g, denoted by small g. Okay, so here why do we use the gravitational acceleration? In the chapter on motion you read that when a body is subjected to a force, an acceleration is produced in the body. So that means, for example, we are applying a force, some energy on our friend, and we are pushing the friend with some force, and some friend is changing the place. Yes, there is some movement is there, some direction. Okay, so acceleration is produced in the body. That means some speed is, some movement is produced in the body. Okay, so that is the one. The acceleration produced in a body due to Earth's gravitational force is called as a gravitational acceleration. Underline this point. What is a gravitational acceleration? Acceleration produced in a body, some speed, some movement produced in a body due to the Earth's gravitational force. Due to the Earth's gravitational force. So it is called as a gravitational acceleration. Gravitational acceleration is denoted by the small g. And from equation 4 means this is the one, capital F is equal to g m1 into m2 by r. So that means gravitational force is directly proportional to the mass of the bodies, but it is inversely proportional to the distance. G is the gravitational constant value. Okay, so that is the one. So with the help of a Newton's law of motion, Newton's law of motion is, if we say the equation, that equation only we have read, F is equal to capital G m1 m2 by r square. Okay, we can find out the value of G. Suppose the body of mass is placed surface of the earth. Earth exerts a force F. Okay, the body. So when we are standing on the earth is applying some force on us. Okay, on our body. That is how we are able to stand there. So capital M into small m. So here capital M is what we will see, mass of the earth. Capital M is the mass of the earth. Capital R is what? By r square. Na? Here it is not proper. See the textbook 161. F is equal to capital G, capital M into small m by r square. Here capital M is the mass of the earth, weight of the earth. Capital R is the distance of the earth's surface from its center. This is the earth, na? So this is the center. Okay, so the distance between the earth from the surface to the earth. Center, its center M, mass of the body. So something is here. So from that to center of the earth, this distance is the capital R. So this is the earth. So how much acceleration will be produced in the body due to the gravitational force? So due to some gravitational force from the earth, how much acceleration, that means how much movement there in the body. Okay, so that is the one. Second, the second law of motion. What is the second law of motion? The rate of change of momentum an object is directly proportional to the unbalanced force. Some means some force we apply only, there will be change in the motion. That means, for example, I am applying a force on my friend. Friend is beside me. I am pushing her with some energy. So that friend will be changing the place. So the friend will be moving. So vehicle is in one place. We are applying a force on the vehicle. Energy, we are giving some force, so that vehicle is moving front side. So this is the acceleration is produced in the vehicle. Okay, so like that, na? So small m is mass of the body. Okay, so second law of motion means what? Unless we apply a force, there will not be a change in the motion. So it is the one. Okay, so according to this one, F is equal to mg. G is the acceleration, F is the force, m is the mass. Okay, so this is the one. So here, after finding everything, you remember only this value, it is enough. So mass of the earth is always what? 6 into 10 to the power 24 kilogram. And R, distance between the center of the earth and the body is how much? 6.4 into 10 to the power of 6 meter. Okay. So on calculating, we get the value of G, 9.81 meter per square. For simplification, G means what? Gravitational acceleration. Here how much? 9.81 meter per second square. So that much is the distance. That much is the acceleration is produced on the body. For simplification, we will put the value of G as 10 for all mathematical calculations in this chapter. So 9.81. The value of G, gravitational acceleration, is value is always same. That is 9.81 meter per second square. Otherwise, we can say the 10 meter per second square. Okay. So, does the value of G depend on the mass of the body, volume, nature, density, position above the surface of the earth, or the distance from the center of the earth, which all factors among us, these are more important. If the value of G on the equator of the earth and the poles same, equator means, so this is the earth, na? This middle line is the equator, this point is the pole. So this gravitational value, is it same near the equator and near the poles of the earth? So asking the question, okay. So this acceleration value is how much? Gravitational acceleration value is how much? 9.81 meter per second square, otherwise 10 value. So this gravitational, this is the earth, here is the center, and here is we are here, our ball something is there. So this is applying, giving, earth is giving some force on the ball, so that ball is moving or coming back to the earth. So this is the gravitational acceleration. So that value is how much? 9.8 meter per second square.